Lovely to see so many familiar faces. I'm going to crack on. I'm also going to be very strict on timing. Ahad, I'm assuming we've started 15 minutes after the original schedule. So I'd firstly like to introduce Peter Fisher. Peter is at Bennetts Associates and pioneers sustainable projects. Peter studied architecture and environmental design, a great two things to do together, and has taught and lectured extensively on architecture and sustainability. He is currently involved in several zero-carbon projects using timber and reuse, and is currently working on Timber Square in Southwark. Peter is going to present Facades and Upfront Carbon, Is Curtain Walling Dead? So all of you in the aluminium industry out there, be aware. Thanks, Peter.
Thank you, everybody. A bit like I might be walking into a hornet's nest. And the one thing I'm not going to do is answer that question. Is curtain walling dead? I don't know, is the honest answer. But this is the, musings or reflections on where we are and quite a bit about where we've come from. I think one of the most interesting things in architecture is actually architectural history, so that we understand where we've come from, and we learn a lot of lessons from that. And at the moment, there's lots of things. We're just having a conversation about circularity, and this applies to so many things where we talk about net zero carbon and circularity as though they're new things, and they're not. Not being circular, not being zero carbon, those are the new things. And so a lot of the lessons for us actually lie in the past. And so at a facades conference, I'm going to start with the Great Pyramid at Giza. It's estimated that the carbon to build this is the equivalent of a small office building in London today. And all of that carbon was biocarbon, not fossil carbon. And yet it was the tallest building in the world for about 4,000 years. And if we look throughout almost all of history, we're just in a blip, the carbon blip at the moment, all the way through history. The pyramids, the Romans, medieval cathedrals, along the bottom, time. We were zero carbon, net zero carbon. There's no fossil fuels being used. And it's only really when we get to the rebuilding of London after the Great Fire, the early Georgian period, where we started transporting coal from Newcastle down to London, because it was much easier to do that, to make bricks just outside London, than it was to transport stone, because we could use water. And that is the beginning of the carbon age that we're in. And we need to rapidly decarbonize. I don't think anybody in this room would disagree with that. The simple question is, how do we do it? And many of us don't know. It's a conundrum, it's difficult. Part of it is about looking backwards. And you will probably often hear the built environment is 40% of carbon emissions. The construction industry portion of that is 11, 12% of all carbon emissions, more than double aviation. Now, there are lessons in buildings like this. Presuming, I'd be interested if anybody does know what this building is. I think it's probably the most significant building of the 20th century. It's called the Millen Building. It's in San Antonio, Texas. It was built in 1928. And it's the first building in history for human habitation that had air conditioning. Air conditioning had come out of the meatpacking industry, particularly in Chicago. And this was the first building that applied air conditioning to it. And it's interesting for many reasons. It's interesting for what it unleashed. It's also interesting for how it itself was. And at this point, air conditioning was merely augmenting the environment of the building. The building isn't totally dependent on it. It's got small windows, it's got opening windows, it's got thermal mass, it's got lots of brickwork on the outside. If the air conditioning in this in 1928 broke down, the building would still be habitable, because it was broadly like all the other buildings being built in Texas at that time. It was habitable. It wouldn't be quite as comfortable. But it unleashed loads of change. And then we move forward. Well, actually, we don't. The first image here is 1928. Just for clarity, some people, I've done this before, and some people think I'm having a go at Mies. I will say the only fridge magnet on my very crowded fridge at home that I bought is a quote by Mies. I love Mies's work. And I would have been as wrapped up in this in the 50s as everybody else. But we start on the left with the Friedrichstrasse competition in 1928. This was a competition that Mies did. It's one of the most iconic images of modernism. Had that been built in pre-Second World War Europe,
it would have been uninhabitable. We had the cladding technology, we had the structural technology, we had the lifting technology, but in comparatively poor, comparatively technologically backward pre-war Europe, we didn't have environmental systems that were beginning to emerge in America. So that competition, oops, wow, I got quite a lot of myself there. That competition could not have been built. And yet we wind forward to 1958 in New York, and Mies can then build the Seagram building. And that remains, in my view, one of the most beautiful modernist buildings built. But increasingly, the building was separated from its environmental systems. In effect, architecture was liberated from the need to temper its environment. And that allowed architecture to completely ignore its environment. And then you get forward, I happen to have put in Michael Gray's Portland, Oregon building. You get postmodernism. The architecture is literally becoming paint on the outside. It is wafer thin. Architecture has lost all its meaning, its tectonics, any relationship to its climate. And that has unleashed something hideous all over the world. And now we have often completely rootless buildings. They're the same all over the world. They look the same. It doesn't matter whether they're in a desert, whether they're in the Arctic. They're beginning to look very, very similar. Cities look very, very similar. And that tells us not anything about a solution, but it does tell us what the problem is. And we cannot have internationalized solutions. We can have internationalized technologies, but I think many of the solutions lie much, much closer to home. And if we begin looking back, I think there are incredibly profound lessons to be learned from vernacular architecture. And very often, vernacular architecture is responding both to local climates and also to resource availability. And that is telling us a huge amount about how we can, lead more environmentally benign lives. And whether it's, extremely arid, extremely hot climates with massive diurnal swings where we're losing local mud, or it's very, very humid tropical climates. And we could go on and on and on. We could just do an entire, encyclopedia on vernacular architecture, the materials they're using and the climates that they're responding to. And that gives us many, many clues in many respects. And then I was just going to come on to this image. Now, the graphic on the left-hand side is a series of curves done by a physicist called Nick Baker in Cambridge in I think it's the late 80s, early 90s. And he was trying to develop some curves that were about glazing ratios. And I was a student of Nick Baker's. And I was very excited by this idea that, dependent on what you were doing, where in the world you were, which way you were facing, that buildings would be modified and tempered really by climate and their response to climate. And this was taking into account everything: heat loss, heat gain, loading, heat loadings, daylighting, etc. And we did quite a lot of parametric studies of this. And the slightly disappointing result, in my view as an architect, coming out of that was it was almost always the same answer, irrespective of where you were, what you were doing inside the building, and which way you were facing. And that answer was somewhere usually between 30 and 50%. And hey presto, that is a Georgian terrace house. They're almost always about 35 to 40% glazing ratios. So in a sense, we know what the answer is. That is probably where we should be going, not aesthetically, but that's probably where we should be going. That's probably always where we should have been. But we have a problem about a culture of how we build and how we conceive buildings that probably prevents us doing that, certainly in temperate climates. And then today, as we move into a world that is much more understanding, certainly of its impact, if not what it can do about it, playing that with new buildings, playing off operational and embodied carbon becomes very, very interesting. And these curves are altering quite a lot. What this is showing across the bottom is ongoing operational carbon emissions from a fairly typical British office building. And it's declining slightly due to grid decarbonisation. The dotted line is then the cumulative carbon emissions from that building. And what you see is that the upfront carbon and the embodied carbon, or the upfront carbon, never, ever meet. And all of the pink carbon on that side is emitted before you even occupy the building. So people will be familiar with that as a notion, but I think the differential between them is absolutely vast. And that's probably where curtain walling and the facade systems that we use have the biggest issue. Now, what we do know is things are changing. They're changing fairly quickly, and I think we've got to move very, very quickly. And one thing that's going to help us, I think, a great deal is the net zero carbon building standard that's been worked on at the moment. That's going to give us clear science-based targets for both operational and upfront carbon. And I think that will probably become a standard. At the moment, there are many, I often talk about net zero carbons in the plural. That's probably going to give us a singular definition across at least 13 different sectors. And when we start to look at the impact of facades, it's generally, we think, somewhere between 11 and 15% in most cases. And I would say in the last 5 years or so, we have made enormous strides on superstructure, less so on substructure, but on superstructure, the move to biogenic construction. So that portion is slimming down considerably. I'd say we're halving it at least. The facades generally haven't moved. And there are mutterings, but the facades have more or less remained the same, bar one or two slight changes of emphasis or nuances in recycled materials. But it's probably about the same, but proportionally, it's getting much more significant as we make greater inroads into what are the much bigger proportion. So we've been trying for a while to get to what will our target be? What do we need for the surface area of facade as a target? And if we work through the Leigh targets at 350 kilograms of CO2 per meter squared GIA, and through general facade areas, floor to wall ratios, we get to a target of somewhere like 150, probably closer to 100. Now, as many people in the room will know, 100 kilograms of CO2 per meter squared is basically a double glazed unit with nothing else. So that's the challenge that we have. And so what we've been doing is working through a series of parametric studies. The intention is not that anybody can read this, rather that what this is doing, we've realized that the substrate is actually way more important than the cladding itself. Across the top is a cladding type, down the side are substrates, and curtain walling, of course, is all of those. And you will notice these are loosely based on as-built projects of our own, or projects that are in the office. And there is nothing in the curtain walling world that comes anywhere close. These are all 300. The best we're getting is 250. The only one that comes anywhere close is on the right at the extreme left-hand side, which is the my left-hand side, your right-hand side, which is beginning to look at timber unitized systems. And I think we're really not there with that. Frighteningly, if you were religious about the carbon on this, probably the best outcome is hand-laid brickwork on an SFS backing. And that is certainly not where the future of the industry is probably headed, or probably should head. But if you were religious about carbon and nothing else, that's probably where you would go. So I said these are some sketches of a recent project where we're working through different substrates mostly, and it was the brickwork that comes out best. That, incidentally, is not what we're doing. It's because of the way in which it is built. But as said, I think we're making significant improvements on structural carbon. We're making much less progress at the moment on the facades. And they said, we do know that there are curtain walling systems becoming available. There are timber ones that are, well, they're sort of getting there. But every time that those come on stream, we're not doing very much in that world, despite trying. And we think the carbon improvements are probably about 25%, but that still doesn't get us close to that 150 target that we need. And we think that there are some fire compliance issues around those. And again, this is embryonic at the moment. I still don't have available data that I trust right now around systems such as this, neither on cost nor carbon. But they're definitely headed in the right direction, I think. But whether or not this is actually the answer, I don't really know. I think it might be making the problem slightly less bad, but it is probably not the answer. Now, I'm coming into probably the last three slides at the moment. The reason for putting up this is an office building that we're working on at the moment. It is a mass timber structure. It's a 9-story building. We're at stage 3. It's got planning. About 40% of our workload as an office now involve structural timber in some way. And I think if you go back only 5 or 6 years, if you'd said that we would have mass timber commercial office buildings, I think that would have sounded slightly deluded. And it simply wouldn't have seemed real. Yet we're at a point where about 40% of our workload is exactly that. So the penultimate slide, is stuff that we're actually looking at the moment. And some of this probably seems completely unreal at the moment, or naive, and I think some of it probably is. But I think we've got to keep our eyes on what those might be. And we are looking at rammed earth on the outside of buildings up in Edinburgh. We are beginning to look not just on a private house, but increasingly on a 6-story office building at using modularized straw. And that, if you begin to think of it as a SIPS panel with a different insulation, becomes psychologically slightly easier to handle. And the final one is a couple of buildings that we're looking at now, which are using structural stone with cross-laminate timber structure inside and nothing else. And once we do that, that is very low carbon. That gives us a bit more to play with when we get to the glazing. And so the final thought, really, I said, not answering my own question posed at the beginning of this, but these are a couple of buildings. Wessex Water, which is over 20 years old now, where we reopened a quarry. We were able to use local stone on that one and elements of curtain walling. And then a project in the city, which is, it's not actually structural stone, but this is something that we're looking at the moment, replacing the concrete back into this and holding up the building with it. And I think that may be one of the answers going forwards, but I'd be very interested in other people's views. Yeah, I think the answer to my own question that posed at the beginning is probably just 3 dots and a question mark. I still don't know where this is going, but I hope that was of some provocation, but not too much. Thank you very much.
Peter, thank you very much. I think there's a lot of food for thought there. Maybe it's more of a matter of we need to rethink curtain walling and how it's used and the other materials we use with it. So a great discussion. Peter will hopefully be available a little bit afterwards if the curtain wallers would like to discuss it further with him. Sorry, just one reminder to all the speakers. I have been asked if after, at the end of this session, if you can all remain behind just to receive something from the organisers. So I just wanted to put that in. Our next talk, I'm very glad to say, is Glass, A Circular Journey. And that's being presented by Brody, Isaac from McLaren. Brody is Head of Sustainability at McLaren Construction. He specialises in decarbonation of site activities and the delivery of net zero carbon buildings in construction. Brody has won the Sustainability Champion of the Year and Sustainability Strategy of the Year awards at the Shift Sustainability Awards. We also have Claire Tribe. Hello, Claire. Claire started her career as a quantity surveyor and has spent the last half of her career in a pre-construction role, focusing on design and procurement of major projects in London. Claire has developed technical expertise in procurement of facades. Claire is very interested in sustainability. She was shortlisted for Best Woman Contractor at the Women in Construction and Engineering Awards and awarded a Group Chairman's Award for Building Sustainable Communities, Community Legacy. Welcome both of you. Thank you. Do you want to come up and you've got 20 minutes.
So I'll just introduce McLaren first of all. So we're a £1 billion company, principal contractor. We're working on Portland House, Landsec, one of their big ones, IKEA on Oxford Street, and Excel, just to give you a few. But we have a problem, not just McLaren, but the construction industry, and that is that 1% of all building waste goes back into a building. I'll just let you think about what that actually means. So all the material that we're putting into the building, 99% of that has come from virgin sources. And what we're trying to get at is to a linear, to a circular economy. And you can see that the linear aspect is where waste will come straight out of a building and then back straight either into some other types of form. Recycling is great, but it eventually ends up either in landfill or in some other low source recycled terms, but the circular economy is where we want to get to. I'm obviously telling everyone to suck eggs here, but using it again and again and again, where we have a finite planet, that's where we need to get to, because that 1% isn't going to cut it. The London plan is really trying to get at this. With the circular economy statement, we've got it comes up forward with 20% recycled content is what the challenge is. It doesn't stipulate whether that should be recycled or reused. The recycled element is really helpful when we're purchasing material, but if we're thinking about the material that's coming out of buildings and that 1% that we need to get back, there's a real challenge there. So a lot of you probably know what this is. Marks and Spencer's in Oxford Street. A lot of this in the news at the moment. The first time that the government has quoted net zero carbon 2050 targets. Apparently, it's not in line with them targets. And that's because of the embodied carbon, which we heard about earlier, and the reuse aspects of it. This is pinnacle. It's the first time it's ever happened that sustainability legislation is stopping a building being developed. Think about the reuse aspect and how that's going to have a knock-on effect. Claire.
Okay, so today we're here to talk about, which you have probably heard about quite a lot this morning, that zero waste hierarchy in terms of the reuse down to the disposal. And when we first started this journey, there was a lot of feedback from the industry. Yes, we recycle. Yes, it gets recycled. When you probe that into it, the actual material was either being downcycled, repurposed, or disposed. On the next few slides, I will give a few examples. So I think the only example currently that exists for successful reuse, I know there are some projects in construction at the moment, is British Land's Triton Square, which is on the right-hand side, which has reused all of the glazed and aluminium units into the new build. Then we have the recycling, which is effectively the only contribution to low-carbon glass, which is end-of-life material taken off dismantled or demolished buildings. And then probably the most common themes at the moment of where the glass goes is either downcycled into glass bottles or repurposed into road coverings, also into items like mineral wool, etc., on new buildings. So where are we now? So I'll pause on the picture on the next slide in a second, but effectively where we are is the pre-consumer waste from the production closed environments that are quite hygienic. Going back to the processing is really working, and that has been working for many years in terms of waste cut-offs on the pre-consumer lines when the units are being manufactured. What isn't working very well is once we've built the buildings and they've been in use and they've reached the end of their life, is getting that post-consumer material back through the value chain, back into the production lines, into new construction materials. So I'll just pause on this slide because I think this picture here shows exactly the reason why it's difficult and why it's a challenge in terms of the whole logistics piece that we'll come on to. Here you can see a picture taken at Ali Trade. At the front here are the windows from Chalcott's estate, which are effectively the post-consumer material. In the rear, you can see the pre-consumer material. So you can really see the difference in the demolition material that we're taking off the buildings and why it is difficult to get this material back into the new products. Then in terms of why we got on this journey, this is probably a bit of a historic slide that David will update everyone on later. In terms of Saint-Gobain's figures, I think this started 2 years ago at Zak, and that's how we entered into this process with Saint-Gobain to help them increase their post-consumer cullet, which is currently was at the time running at less than 1%, but we'll get an update on that later this afternoon.
So we've gone through really the problem, bit of like the methodology, and we're trying to get to that circular aspect away from the linear, but then what's actually being done? And this is what we're here to talk about. One of the projects that we're working on, Chalcott's estate, London Borough of Camden, 4 23-storey tower blocks with over 3,500 residents in situ. So they're there, they're not moving it, they're not coming out. What are coming out is the windows and that aluminium facade. And you can see some of the numbers there that we're talking about. This is post-Grenfell. You know, the cladding had to come off, putting it back on. There's a lot of reuse items here that we're trying to promote. But we had a problem. London, so we were powering with Saint-Gobain and Power Day and Alley Trade for the aluminium, but we're talking primarily about the glass with Saint-Gobain. The logistics. London, the red one is Saint-Gobain. How do we get it up there? And also, how do we process it? These are the main barriers when we're talking about circularity. And that 1% is how do we get it out, process it, back to the manufacturer. This is just a nice little diagram of the linear economy would be the waste bit coming out the bottom, the circular going back to the manufacturer, and up Saint-Gobain, Power Day, Alley Trade were helping us in there.
Okay, so then just a bit about the process that we undertook at Chalcott's. So effectively, we purchased one of the Merlin lasers, which you can see on the screen there, relatively cost-effective to purchase, and we effectively went round and audited the circa 3,500 windows. Obviously, at the time when the project commenced, the monolithic glass was the primary focus for recycling, and fortunately, both panes of glass in most of the highest percentage of the building were monolithic, so they were suitable for recycling. So from that audit, we established that the glass could be recycled. Oh, back. So then the next part was dismantling the units. So as Brody has said, we went through a number of journey that's here. It took us about 18 months to get this process sorted. Originally, we were looking at sending the glass back on stillages in one piece. In the end, we partnered with Power Day to put a processing factory in their North London facility to be able to process this glass. So effectively, we take the glass out on stillages, and we now are loading those onto timber pallets that then are effectively stored in skips. So on here you can see we have segregated the waste. So on the left-hand side is the Power Day skip, which the glass is put into, and then on the right-hand side is the aluminium frames that then go to Alley Trade in a separate skip. So we segregate the waste at site level. Then, in terms of the processing, this is the machine, which is a Saint-Gobain processing machine that is at Power Day's facility. That glass is taken in the skips to Power Day's facility. They then process that glass into what we could see cullet on the left-hand side into bags. Then I know we're primarily here talking about glass today, but I think it's important to know what happens to the aluminium. That is effectively goes to the Alley Trade facility in Birmingham, and then that goes for a shredding process. And it's worth noting that every part of that waste is actually recycled in some form, and then that is sent back to remelt to hydro. Then the glass from Power Day's facility is bagged into the tonnage bags and picked up on return deliveries from Saint-Gobain. So when they deliver the sheet glass down to the processors on the return journeys, they pick up those bags on specially adapted fleet vehicles that take that material back up to Saint-Gobain's facility in Eggborough and goes back onto the float line to post-consumer material into the new glass production.
So that's really important, the process. You know, this just doesn't happen overnight. This is something that needs to be worked at, and, you know, working with supply chain partners, a lot of technical knowledge, you know, the likes of Power Day and like how the material needs to get there and what state it comes in is really important. So just to give, we estimated on how much carbon we were going to be saving. Just for those out there who would like to know, 1 ton of cullet equals around 700 kg of carbon savings. That's across its life cycle. The project is going to be aiming to recycle 90 tons of glass, which equates to 63 tons of carbon, which could power and heat 24 homes for an entire year. Where we're currently at 10 tons of CO2, 10 tons of glass with around 8 tons of carbon being saved. So there's still a long way to go on this process. But it hasn't been plain sailing. All the process that we went through there seemed quite straightforward, but we've learned a lot of lessons along the way. First of all, the one on the left here, this was the first delivery that came to Power Day. There was broken glass all in the bottom of it. That had a shovel, and then it was put into the bag, which is what you can see here. It's safe to say that Saint-Gobain were not very happy when that arrived, because you cannot put dirt into their glass manufacturing process. Also, we started to get, it was smashed, you can see that, and then it started to get better and better throughout time when we were having to go through it. Again, it was being kind of discarded, not very well. Lots of other bits of trash were in there. You can see some like tape or something like that at the bottom. But through a lot of work with the people who were operating it, the waste contractors who were dealing with it, we managed to get it to that top right picture. And finally, where we managed to get it at optimum levels, this took a few goes to get it like this. We put it on the wooden stillages, so we had a forklift being able to take that in and out of the back, and we also tied it as well, so it wasn't going everywhere and breaking during the transport. Now we've got a process that works, that you know, I think is relatively simple to follow. But what's next? So this is really a unique selling point that McLaren is bringing to the market. It's worth saying that this is now available for everyone, and we're going to talk about contact details if you're finding this interesting about how to get involved. But yes, Spring Gardens, we've just managed to confirm that we've won this project. There is some film glass on there, but we've been able to highlight that this is something that we're going to be able to do on the project. It's helping us with work winning, and every client that we're talking to, you know, like the landowners, the developers who are refurbing their projects, want to know about this. There are still challenges, though, for the industry. Film glass and laminated glass are still throwing up a lot of issues, but David's going to be coming on from Saint-Gobain later. I can see him flexing his muscles at the back there, about how we're going to challenge this as an industry. But this is my most important slide, and the bit that gets me excited, the scalability of this. What we've done, yes, is innovative, but at a relatively cheap cost, we've been able to open up reuse in one way to the London market. So everyone in the room who's either dealing with a retrofit project, is getting glass or a facade taking off, this is something that you can do now, albeit within London. But there are individuals who we'll talk to, I'll show you their contact details later, about who you can talk to get something set like this up outside of London. So just a bit of a summary then from everything that we've spoken about. Early engagement in this is absolutely key, because where we're going in and talking to clients and the demolition contractor has either already been signed up or the contract's been agreed, reuse, whether we're talking about glass, steel, aluminium, plasterboard, it's usually just being ripped out, thrown into a skip. It might be segregated, but this does take planning. And if you're going for the cheapest option, reuse is not the route to go, then that's just a fact. But we obviously realise as an industry, we need to get better at that. Collaboration, you know, we've already highlighted Saint-Gobain, Power Day, Allutrade, but there's loads of reuse schemes out there, and it's not just to do with glass. There's a lot of other building elements that we need to be looking at as well. I've touched on the scalability bit and how that we all need to be able to we can all get involved. The journey's certainly not over. You know, let's really challenge that 1%. We need to get better. We're a finite planet. 1% of waste coming out of a building from refurbishment isn't going to cut it. And that's where the industry investment and involvement gets. Everyone in the room can in some way push this agenda so we can challenge that 1%. So this is the bit that if you wanted to get involved in this, these are the people. I'd say take a photo now if it is something that you think you can get involved in. Anthony Davitt from Power Day and Richard from Saint-Gobain. David, I left you out because you're coming up next. Thank you very much.
Thank you.
Thank you, Claire and Brody. That was fascinating, and I really do think that you've shown that it can be done. It'd be really interesting, actually, to get from you an idea on how much it added to maybe the demolition programme. Would be fascinating. Maybe some people can ask you afterwards. But I think it's fantastic. You know, so often in construction we'll say it's too hard to do, but no, you guys have shown it can be done. Anyway. This works very well because, as they said, that the lovely David Entwistle, I may say this, I have known David for well over 20 years, is going to talk to us about sustainable glass solutions for building envelopes. David is head of major projects at Saint-Gobain and has been involved with the London facade community for many, many years. Not only at Saint-Gobain, but also working for specialist facade contractors on complex facades. I changed your bio to say you have recently completed the MSc in facade engineering. David is passionate about sustainability and improving recovery of end-of-life glass back into building glass. So David, please do come up. And you've got 15 minutes. Oh my God, that's impossible.
2 years I've stood on a stage at this event and talked about recovering end-of-life glass. I was about to say, people say I go on like a cracked record, but it kind of ruined the joke because the record wasn't on the screen. But anyway, let's try and move on. So, life is about choices. Anybody recognise where this is from? So 1999, a film came out called The Matrix. It was a film about people in dodgy overcoats with sunglasses on, fighting against people in dodgy suits with sunglasses. They weren't real people. And what they were actually trying to do is they were actually trying to defeat artificial reality created by machines that was controlling people. Does that sound like AI to you? Maybe. And so we have this scene where Keanu Reeves, who plays Neo, meets Morpheus, played by Lawrence Fishburne. And he holds out 2 pills to him. And he says, are you going to choose? And these are the words he uses. I can't do accents. But this is what Lawrence says. This is what Morpheus says. He says, you can take the blue pill. The story ends. You wake up in bed and believe whatever you want to believe. You can take the red pill and you stay in Wonderland, whatever that means. And I will show you how deep the rabbit hole goes. So what am I saying through this? That's a very good question. There's a few people sitting there going, where the hell is this guy going? So it could be that I'm giving you a choice. And I might say, you might learn something today that means you might have to react. Or you might learn something today and dismiss it and go back to acting as normal. And what do people say? They say, you know, stupidity is doing the same thing and expecting different results. So what has got to change here? I might also be saying, well, maybe I'll give you a choice today. You can have a choice between a nice corporate video, waterfalls, blue sky, green fields, or I can actually talk to you about the real challenges of getting commercial glass off buildings in London. Maybe we should have buzzers on the desk. You can choose which would you like to see. It can be the nice corporate stuff on their seat, or would you like to hear the real stories? Well, I'm going to assume everybody here wants to take the red pill and hear about the real stories. Yeah? Is that a fair assumption? You can give me a bit of feedback if you like, it's okay. So, you know, some of the challenges we face, and again, talking about reality, talking about what's actually happening. I'll just give you an example of a few challenges. It's fantastic today that a number of companies within our industry, within the glass industry, are producing a low carbon glass. And obviously, more EPDs are coming out as time goes on, which is great, which is really important. And on the one hand, it's fabulous. What it's doing is, it's proving the actual benefit, the immediate carbon benefit of using cullet in glass process in terms of its carbon reduction. So that's the positive. What's the negative? Well, the negative is the average recycled content, end of life in new glass, whether it's low carbon glass, whether it's standard glass, is less than 1%. So, hold on a minute, we're being sold this slight dream, low carbon glass, but what you're actually telling me is the end of life content is minimal, to say the least. And the answer is yes, that's what's happening. So, what's happening is we're all fighting over pre-consumer, which is the stuff you buy from the glass processes, we're all fighting over pre-consumer glass to make a product that we're calling low carbon. Now, I say, I don't want to throw the baby out with the bathwater because it's important because we're proving a principle of the immediate carbon reduction of a high recycled content. But where we get the glass from, well, you might struggle on some to find the truth. But the fact is, that is where it's at. Oh, I'm being... Oh, can't hear me at the back. It's funny, nobody's ever accused me of having a quiet voice in my entire life. But anyway, there's a first time for everything. All right, and the last thing I want to say before I move on, because time is ticking down on me very fast. The last thing I want to say is that, you know, you can get... one thing I've been talking a lot to people about is that we cannot disconnect low carbon from circularity. And it sounds a weird thing to say, but it is possible to make low carbon products by using renewable energy, but they're not recyclable. And for me, a key part of our strategy going forward has to make sure that we connect circularity with low carbon, because if they get disconnected, we make ourselves feel better, but we're still digging loads of stuff out the ground and using up valuable resources. So it's really important that we tie the two things together. Anyway, let's move on. So we're going to talk about a study from 57 interviews, in-person interviews for 1 hour, and we're talking about interviews with clients, we're talking about meetings with developers, architects, main contractors, facade consultants, demolition contractors, waste management companies. So we've done our research. I want to talk to you about how that affects how we look at scopes and what that means to us. Scope 3 is a real game changer in our industry. And then we've got embodied emissions in there as well. And then the last thing is just what does that mean in terms of a strategy for recovering end-of-life glass? And what are we doing about it? And the fact is, we are doing stuff about it, and we will hopefully tell you more about it. We're now working. All right. So the first thing is I want to talk about the results from the study that we did. So, I just finished MSc qualification. I graduate end of November, which is fabulous. And one of the things I did for my dissertation was interview these different groups that you can see up there for an hour, talking about what they would do about end-of-life glass, why wasn't it working, what could we do. And you can see 14 clients. And just to give you an idea of the people we talked to, and these were all director-level people, we talked to people like... I can't even find my list now. British Land, Argent, Land Securities, Great Portland Estates, on and on and on. All those sorts of people were the people that we actually talked to about this subject and trying to get their opinion. So what I'm going to try and do is I'm going to try and actually distill down the responses they gave into 5 questions, and we're going to run through each one of them in time. So the first question we said was, what happens to end-of-life glass? Now, across the whole range, most of them identified that probably the demolition contractor did something with it. But when we kind of dug a bit deeper, said, well, do you know actually what happens to your glass? End-of-life glass of commercial buildings in London. 50% of the responders were honest enough to say, we don't really know. Now remember, less than 1% of end-of-life glass finds its way back into new building glass. So where the hell is it going? 50% of the responders didn't know. Is that shocking? Is that surprising? Don't know. And then basically the rest of the people just came up with various answers about being crushed, segregated, etc., going to landfill. 50% of facade engineers thought end-of-life glass was going to landfill. Not really in London. And then 50% of client developers thought their end-of-life glass was being segregated on site, but they couldn't actually prove that it was, which was kind of interesting discussion, perception versus reality discussion. All right. There we go. So why is glass not recycled? So virtually everybody used this phrase, and it's a really interesting phrase. They said, there's no reverse supply chain. Now, when you said to people, well, what do you mean? They just said, we don't know who to go to. They couldn't really express what it really meant. They said, we don't know who to go to. We don't know what to do. Who's going to deal with it? And then obviously time and logistics were part of the issue. For the facade consultants, technical issues became quite prevalent in terms of, well, what do you do about contaminants, and everything else. But this point of the lack of a reverse supply chain has become very much a theme of how do we actually move forward in this area. So for the client group, and the client group are very key to unlock this whole situation, 93% of all their responses revolved around lack of a reverse supply chain and time and cost. And you kind of would expect it, but it's good to actually realize that those are the key issues for the clients. And so what does that tell us? Well, we'll come back to that in a minute. What's driving current practice? Well, we know that within London, and it's been talked about already, the planning requirements, the circular economy requirements, pre-demolition audits that make assessments of carbon. People are doing stuff about the concrete, people are doing stuff about the steel, and as you start to go down the list, glass, aluminium start to appear in terms of the big embodied carbon things. And again, it was really interesting, the first guy that spoke when we came in, embodied carbon. I cannot tell you how many times during the interviews I had to say to the person I was interviewing, you have not mentioned operational carbon. Why not? Why have you only said embodied carbon? And the fact is, I think more and more people are realizing that the embodied carbon, and I think the point was made earlier, the embodied carbon is being spent today. The operational carbon is being spent over the lifetime of the building. So if we're to do anything about trying to limit the effects of climate change, it's what we're doing with the carbon that we have today is becoming more and more important. And obviously, operational carbon is improving because of renewables and energy efficiency and everything else. And the last thing, green building labels, LEED BREEAM, everybody wants them, everybody likes the tick in the box, but generally seen as being a little bit ineffective in terms of actually affecting circular economy thinking. And those things I know are changing, but are definitely part of the slight challenge there. So when we said, well, what would change current practice? Not surprisingly, a lack of a reverse supply chain was seen as a barrier. So if we have a reverse supply chain, then maybe that can work, providing it can work in with a time cost scenario. And that is a big deal. And we've talked about, well, we've heard stuff about Chalcots, and we'll cover that in a little bit as well. So, and then we see the client group who are squeezed by the issues of planning, the issues of circular economy and planning. They're squeezed by the ESG requirements of their investors, and they're also squeezed by the ESG requirements of their tenants. So they're sitting in this kind of perfect storm and realizing that they have to do something to address it. And this is where we come in there as well. And then I think probably the last question we said, well, who should be driving this change? And I think everybody would recognize that if change is to be far-reaching, it needs to be driven by government, okay? It needs to be driven by government. Now, whether that will happen and when it will happen is anybody's guess, but because the client group in London are sitting within this environment of being squeezed from all sides, they are very responsive to this change. So they're not waiting for government to do it, they're pushing it on. And what was really fascinating about every interview with a client, they all referred to these other factors, and this comes in this 22% at the bottom. And they talked about, we have a responsibility. We feel a moral pressure. We feel a societal pressure. We feel we have to do something. We have to do something now. We can't carry on doing the same as we're doing and expect different results. And so those comments came through from the clients. And one of the other really interesting things came through was, this is what the clients said. They said, within our businesses, we have a younger generation that is coming through, and they are not happy with the depth and the speed of change. We are being pushed by a younger generation who are saying, we are inheriting this world from you, and it's going to have to be better than it is. And so there's this inbuilt pressure that's coming through these organizations. And again, and the final thing they said was, it's going to take bravery. It's going to take courage. It's going to take leadership to make this change and happen. So where do we go from there? Well, I've got a minute and a half, so I'm going to have to go. 4 minutes. 4 minutes? Oh. Fabulous. All right. So as I already said, nobody's talking about embodied carbon. I can get it done in 4 minutes. And the Ellen MacArthur Foundation said that we have to reduce the embodied carbon in making things by nearly 50% in order to mitigate the effects of climate change. You see a quote in the bottom right-hand corner. I don't think it was from the CBRE, but it's in one of their reports. Without action on embodied carbon, the UK's net zero goal is not achievable. The penny is dropping on embodied carbon in materials. It's the carbon currency that we are spending today. And we are stuck with it once we've spent it. So we have to do something about it, and urgently. All right, Scope 3 emissions, real game changer. Why is Scope 3 emissions a real game changer? Well, for I don't know how many years, we have understood our Scope 1 and Scope 2 emissions. And obviously, the emissions are in the Greenhouse Gas Protocol, 2001, whatever it is. They're defined in there, and you've got these scopes. And so we understand our Scope 1 and 2 because they're from our direct activity and from the energy use that we have. Scope 1 and 2, we've understood that for ages. And so we've always said to people, 1 ton of cullet gives you a reduction of 300 kgs of CO2, roughly. But all of a sudden, we're going, okay, well, we've got to be net zero by whatever date. Pick a date, 2040, 2050. We've got to be net zero across all scopes, and that includes Scope 3. So what's Scope 3? It's what happens in the supply chain above and below us. So basically, we inherit in our carbon footprint the carbon impact of our supply chain. Okay? Their carbon impact becomes our carbon impact. So what's happened is people are starting to get on with this now. So we've started to see these things happen where there are strategic agreements going because people realize they have to align their businesses with companies that can help them achieve their overall carbon objectives, including Scope 3. So I was in Foster & Partners about a week ago, and I said, you will not be choosing your glass in 5 years' time based on appearance. You'll be basing it on what are the Scope 3 emissions. Oh, sorry, Foster & Partners. Anyway, I'm nearly finished. 4 seconds left. I mean, it's great. We're in a vibrant industry where people are continuing to pioneer. We are, and AGC are, other people are as well, which is fabulous. So we brought a low-carbon glass to the market about 1.5 years ago with an EPD. We've done trials with hydrogen in Germany. We've done various things with other people as well. And we've done a zero-carbon glass where we used 100% cullet, renewable energy. Can you buy it today? No, but we trialed it, okay, to prove the point. We're also now producing low-carbon glass in India. So you can't just talk this talk. You've got to make sure you walk it, even in places where the culture is throw everything away. So it's really important you carry on. Right, I'm nearly at the end. So strategy, finally. How many seconds have I got left? 10 seconds. All right. So 3 years ago, I made this little chart on the left-hand side, which was a little bit naive, a little bit idealistic, that we kind of take this glass off the building, we carefully deconstruct the facade, we wrap it in cotton wool, we take it somewhere else, and da-da-da-da-da-da. And then we hit Chalcots, and they were going like, no, can't afford it. And so we went through this whole process from October 2021. We went through this whole process of refining the costs to make it work. And it had to fit in with time and cost. And we went through a whole process, and we brought the cost down by 80% from where we started with this idealistic approach. Now, I'm not saying the idealistic approach is not a bad idea, but it is not scalable. It is not going to work on the scale of project we got. Right, I'm nearly there. So what are we doing today? And I'm just going to give you a tiny peep under the hood of what we're doing. We are on site right now on 6 projects in London, commercial jobs, where we're recovering end-of-life glass. Interestingly enough, Citibank, was anybody there for Yasmin's presentation on Citibank? I went to her afterwards and I said, you don't know this. We have taken 40 tons of glass out of the inside of your building 2 weeks ago. 40 tons. And that's one of those 6 projects up there. So we're doing another job called One Exchange Square. I shouldn't even give you the names. It's top secret information. Anyway, top secret information. And we've got another 24 waiting in the wings to go. So what do? We go to site. We basically give some advice to how we're going to take the glass off the building. And then we work with the existing supply chain. And we then create a joint methodology for taking the glass off the building. The demolition contractors is one part of that supply chain. The demolition contractors then include us in their bid for taking the glass off the building. And hey presto, they win the job. And hey presto, we get the glass. And we return it back to building glass. Sounds simple? It's not. But we're doing it. And I'd like to say thank you very much. And I am done.
David, thank you so much. And again, I'd just like to say, yes, it can be done. I think it's fantastic. You know, we weren't talking about this stuff 3 years ago. So, you know, the last 2 presentations have shown there is a way forward. We've all got to just try harder. Anyway, the next presentation is on the arbour at Bankside Yards. I'd like to welcome Daniel Moore, who's a partner at PLP Architecture. So Daniel has an advanced understanding of facade technology and has developed facades for Francis Creek Building and 4 Cannon Street. And he's currently involved in the extensive development of Bankside Yards on South Bank and the Kaleidoscope project, which is a new commercial building above Farringdon East Crossrail. I'd also like to invite Leigh Easden. Leigh's Principal and Co-Office Director at Thornton Tomasetti Facade Engineering. He has a wide experience globally of different building types and expertise in curtain walling systems and detailed knowledge of facade materials. Leigh is also focused on developing the next generation of facade engineers, which I'm very glad to hear about. Fantastic. Well, thank you, gentlemen.
It's our pleasure to talk about arbour today. We're going to talk about the facades of arbour. Before we do so, I'm just going to give you an overview of Bankside Yards, which is the development that it sits within. Arbour is in the middle there, which is the first building which has been completed. It's a 20-storey office building. It was completed at the end of last year. This is the first major mixed-use fossil fuel-free development in the UK, which is carbon neutral in operation. It's able to be that due to being 100% electric. It utilises a fifth-generation energy network, which allows for energy sharing benefits to maximise the efficiencies. So Bankside Yard sits on the south bank of the River Thames along a stretch which is rich in cultural history and cultural institutions. And we wanted to kind of participate in that as well. As such, there is a cultural institution proposed below the central plaza within the main square, and also some cultural space within the arches as well. So there is Bankside Yards as a master plan is composed of 8 new buildings, 6 new public spaces arranged around these refurbished arches. There's a mix of different uses. There's the 2 office buildings to the south you see there, and then there's residential buildings, there's hotel use, there's retail, cultural, and also leisure. And those uses together create this really rich and vibrant and diverse environment where those uses mutually benefit each other. So Bankside Yards itself, well, that sits on the south west corner of the site. It hovers over the top of a new plaza, Invicta Plaza, but also the railway viaduct as well. As I said, it's a 20-storey speculative office building. To facilitate hovering over the top of the viaduct, we incline the soffit at the base, and correspondingly we did the same to the top for the dynamism. And that creates these quite special spaces. At the top there's this double height space which sponsors a mezzanine floor, and then at the base of the building there's this terraced space between level 2 and 3 which is really good for co-working and other spaces. So, other uses, sorry. So those spaces together with other spaces and facilities together create really good and exciting facilities and space that people want to work in. Create spaces that provide joy rather than somewhere that you simply turn up to go to work. So in terms of the performance of the building, it's a very efficient building. As I said earlier, it's carbon neutral in operation. It's very biodiverse as well due to a huge green roof on the top of the building. But significantly, it's also got a closed cavity facade. So most of you will be aware that a closed cavity facade employs a double glazed skin on the inside and then a pressurized cavity with a laminated glass outer skin. And the blinds within that pressurized cavity provide any kind of like solar shading that you need, which means that the glass can be very, very clear, so it doesn't have a high-performance coating on it. Now, typically you can get up to about 75% light transmission with a closed cavity facade. In our case, we had Low-An glass, as opposed to with a performance glass, you're probably looking at around about 50%. So there's a big, big improvement in terms of natural light, which is going to lower your requirement for artificial light, but also really improves the visual amenity aspect of it. So a little bit about our approach to the design of the envelope. We saw this as this object suspended above the viaduct, but we saw it also as a crafted object, something which could be almost handmade by artisans, which is led by the planning authorities, that they wanted buildings more like the new extension to the Tate Modern, which is nearby, something handcrafted. And we like the idea of doing something in glass. So our first design that we ran with the facades was actually slumped glass, so curved slumped glass sections on a 3-meter grid, where you get a curved section where it's heated in a mold and slumps, and then a section of flat glass as well. So the idea was to provide these vertical ribs, which works with the verticality of the residential tower next door. We went as far as testing the visual effects of looking through curved glass to check whether or not it was going to be producing warped views. We used some very sophisticated software that actually gives the exact glazing characteristics, and we identified that there wasn't so much of a problem. But alas, the client wasn't 100% convinced, and so they wanted us to go back to something which was a little less curved, less warped, and just flat. So to enable us to maintain that kind of like crafted and tactile appearance, we started looking instead at 3-meter panels, which we would tilt in both the vertical and horizontal axis, so that you get this kind of fish scale effect. That only really worked, this fish scale effect, when you did a 3-meter module. But the client and agents were quite keen to actually have some areas of the facades which was a 1.5-meter module, so that modular offices would have a little bit more flexibility for setting out. So we ended up having only on the west and on the southwest elevations the overlapping facade, and then transitioning to flat facades on the north and on the east. And you can see the way that we transitioned so that it wasn't such an abrupt change between the two. So these are images of the finished project. You can see the kind of the agitation, which is quite nice and rich on the facades. And you can also see around the corner how it transitions to being flat from being tactile. You can also see the way that we've kind of like gouged out these kind of balconies and roof terraces and plant spaces out of this object. Now, CCF facades, they're typically fairly flat and regular. There's a couple of examples here. Whereas I spoke to you earlier, I mentioned earlier that we were inclining these panels, which ordinarily would create these tapered profiles on the mullions and the transoms, which, as I'm sure you all know, is not such an easy thing to do, to extrude something which is tapered. But we worked together with TT and with Sheldabao to come up with ways in which we could actually get the geometry to work with sheets, and I think Leigh's going to talk a little bit more about that. That was the initial idea, and then that ended up morphing into something which is a little bit more sophisticated. This is what was finally delivered, where you have extrusions, you then have these cut sheets, cut extrusions, cut to the taper of the cheek, and then it's finished with a closing piece.
might swap places with you and make this a bit easier. And if I knew I was going to be after David Entwistle, I would have worn a louder shirt. So, thinking about the way that CCF works, and this is not new, but with any facade development and design, it's always about compromises. It's understanding all the inputs that are going into it and what's important and coming up with a design that is the best match. And 2017, we weren't necessarily talking about embodied carbon. It was very much more about operational carbon. And so we used the idea of this to start investigating what was the right process and what was the right activation of this CCF based on the other inputs, which is including, you know, how much glass is on this building, the size and width of these profiles and panels. And so we ended up doing parametric studies like we always tend to do, and we started thinking about context as well. Now this is actually from the visual mock-up from Bankside Yard, so we didn't have this at the time, but this is the thought of a transparent glass that has a high G value, which is what was going to match what was wanted for the project. We wanted something that was highly transparent. Compared to another project that PLP and TT did together some time ago, which is Nova, quite typical high-performance glazing, which is a very low G value, but also very low light transmission. And then something a little bit different, the Brunel building at Paddington, Arup Design and TT did some work during the construction phase. We understood what typical office facade glass looked like, and we wanted to do something a bit better. So we ran some of that analysis and come up with a thought of how to make the blinds work, which, considering Steve Bosey was talking about the Paddington Square with the blinds on that, it's a very similar process that we went through. And what we came to was this comparison between a typical office glazing and what we could produce for Bankside Yards, which is a G value which is much higher, a light transmission which was much higher once the blinds were open, but then when the blinds were closed, it was also much higher performing than what the solar coated glazing could do. And through a 3D study, we found that we could get the radiance to less than 100 watts per square metre on the facade, on the inside of the facade at all times during the year. But in fact, that was about 90% of the time less than 75. So we could reduce the amount of solar radiation into the building to 1/10 of what the outside of the facade was seeing. That went a long way to getting the operational carbon working. Back to that original design of the slump glass, and this was a very rough sketch by me, actually at another conference in 2017. And what do you do when you have a complex curved facade? I called Francis Ellington, and we went through it with Cruiser at the time. One of the things about looking at a 3-metre wide module here was having half of it remain flat while one half of it went slumped, and it was very complicated. There was a lot of concern that we could get the visual quality acceptable for the curved glass, but actually we deteriorated the flat glass. So there was also thoughts about how do you make that transom work that has to match the omega shape. There's a lot of work went into that. We also looked at concepts of stiffening up the frame itself, because we knew that the glass curved would be the most structurally defining aspect of that module. So we thought of all sorts of silly ways, including a glass fin in the middle of the CCF panel. We didn't design that. We didn't get any very far with that. But then we went to that change to the more planar approach of the glass, flat glass. And again, we had that thought about the glass is now more simple. It's a more easy thing to produce. So how was the module going to work? And we looked at that concept of modularity, about maintaining the least number of profiles to then actually be able to adapt it. Here it's even an earlier stage where we were looking at multiple profiles, a much more clunky carrier frame system which Schelderbau redesigned into something much more elegant and easy for replacement. But we kept on going through that approach, thinking about how do the longer faces work, the longer profiles, things like where do you put the restraint sockets for the BMU system? And in fact, the trick is it's on the underside. We went underneath. So completely hidden. And one of the other major aspects of this new fish scale design were the cantilevering glass fins on two corners of the buildings. The ones that transition from the fish scale around the corner and then go back to the flat. On those corners, we have cantilevering glass. So back to this as a visual mock-up, but in fact, Schelderbau produced something very similar in size, actually a bit bigger down the longer face, to do as a performance mock-up. We wanted to test the corner. It was very important to get into this, all the different aspects of the glass and make sure that we were going to be safe. And here's a closer view of that cantilever glass. So one of the things we did, it's quite difficult to do impact modelling, and we went through various adaptations of this, of equivalent static forces, dynamic forces, how do you model the deformation of the impact, and we realised that it was good for a guide, but it was never going to be good for the final result. So the only way to do it, as we said before, was to test it. This is another angle. This is actually from on top of the train line itself, which is a place you'll never get to. And forgive the straightness of the panels, Schelderbau hadn't finalised their snagging at that point. It looks much better than that. We did the tests, and I got to give shouts out to Schelderbau, because one of the things they do with their visual mock-ups and their performance mock-ups is they'll do a full report prior to doing the attendance or the test. And one of the things at the end of the report is a list of non-conformances where they haven't been able to produce something to the level that they think they should, or what was on the drawings. And this was also at a time through COVID when we couldn't be physically in attendance. We're sort of fortunate that Schelderbau had their own testing facility. We had time to have it in place. They set up numerous cameras. We had lots of meetings during the days, but we also had the third-party independent authority on site. So we had a lot of coverage. We had a lot of good communication, and it worked. But one of the things in their non-conformities were the day prior to doing that report and sending it for this, getting ready for the test, they reversed a forklift into the corner of the mock-up and broke a fin. And sort of had to put their hand up and say sorry, and my response was yes, great. Now I get a chance to impact the broken fin and understand what that does. Now, we were a bit concerned about impacting at the point of the fracture, so we had to do it elsewhere, but this is not the actual broken fin, but the sort of impact testing that was carried out on a fin that was broken for both serviceability and safety, and we found that there was no further deterioration of the performance. Now we're in a position that we're very confident that this is a good system, even if the worst should happen, because I didn't say, this external glass is laminated annealed low iron glass, so it almost looks like it disappears when you're inside the building. But fracturing a annealed laminated glass, what we were able to prove is it was maintained, it was kept in position, it would not form a danger of falling, and yeah, it was fortuitous, we had time, it was a really good thing to do. So we're going to finish on a few other images of the building and just come up with a few anecdotes from the time, because the process is so long. It was, you know, 6, 7 years, and I'm sure longer for PLP. One of the things that we didn't talk about was the amount of effort that went into the blinds, which included the amount of perforation, the twin colouring, so it's different colours inside out. You do, when the blinds are down, there is a very good visual aspect of what's outside the building. All this was very important. But what we did find, no matter how well they were produced and in a hermetically sealed facility at Schelderbau's factory, there was always dirt, debris, detritus that was in the bottom of the panel. And a lot of it was coming from the blind. And we found that even after the number of uses, more would come off. But, and I can spy Rob Peebles in the corner over here, had a very good idea that we put a shuffle glazing system into the profiles. So to clean that out, it's actually taking away the glazing beads and lifting glass an inch, cleaning all that out, putting it back in place. So for maintenance, it is a remarkably good system. Just looking at the fish scales themselves, and what we found from inside is this external glass is invisible. Once it was clean, it was almost, you could not perceive it. You're standing inside what actually looks like a very thematic feel, because these 3-metre wide windows and these big picture frames that stick out, and then it looks like there's nothing. It was a really nice result.
If you've got the time, do you want to tell the anecdote about the swaying blinds?
Swaying blinds. We noticed on a couple of occasions that blinds seem to be moving within the cavity. Now, they're sealed, they're pressurised, they don't have any stays because they don't need them, they don't really need them. And after observations over 12 months, lots of work by Schelderbau, lots of visits on site, we determined that it was due to the motorised action of changing from open to closed would impart, usually from closed to open, would impart a force on the blind, and they would start to oscillate. And they oscillated to stop at a different period, depending on location, but it wasn't to do with it wasn't environmental, it wasn't sunlight, it wasn't wind. And what we'd actually determined was it was the tolerance of the setting of the blind. The more horizontal it was, the less, and aerodynamics is not my field, but it didn't dampen as much. As soon as it was turned by 5 degrees, they dampened much more quickly. So we're going through a process of now still investigating what is the best setting for these blinds, so that when they turn from closed to open, they don't sit there and oscillate for an extended period of time. It's one of these things where, and I find this in facades all the time, you always discover something new. Every single project, there's always something new. And so we take this information now and it will impart on the next one. But yeah, it was an unknown when we first looked at this.
We're running over now, guys.
So
I think we kind of done.
Just go through the
Just
last
some pretty pictures.
Yes. And that is it. Thank you.
Thank you very much.
Fascinating to share that journey. Really interesting project. Our next speaker is going to talk to us about what to look for from a vertical wall membrane as part of a facade system. And I'm going to ask Allan Hurdle, please, to join us. Allan has worked for many years in the building services industry. And following the Grenfell Tower fire, Allan has been focusing on A2 wall membranes and is a technical consultant for Stamisol UK, a Serge Ferrari group company. He is a strong advocate of independent testing of fire products, coupled with competence of installers. Thank you, Allan.
Okay, thanks for attending, everybody. as we said, what I'm looking at today is actually at the vertical wall membrane. But what I want to do is go into a little bit of a different spin on this to look at all the technical requirements, not just for a membrane in terms of its A2 properties, but for other requirements that the building owner may need in terms of waterproofness, UV control, breathability, etc., etc. And we'll look at all those standards that we effectively go through. So as I said, my name's Allan, and I do some of these CPDs with both REBA, CIBSI, BESA itself, CABE, and I work with BSI as well to try and bring around new PAS arrangements that are occurring outside in the industry. What we're going to be looking at, as I said, is the A2S1DO membranes for outer-wall systems and why we need water, W1 water protection and tightness. Now you're seeing there in some of the slides I'm saying waterproof, as one of my colleagues pointed out, we actually should be saying in terms of the facade industry, W1 as water tightness. So I'll just get that one out of the way as we move on. Here we go. So not all facade systems actually will require a membrane. But if it is selected, we should consider the performance of the membrane and what we are actually trying to achieve to get for it. Because what we'll be looking at is the sorts of tests that can occur, particularly between an A1 and an A2 when it comes to waterproofness. And what we'll also be looking at is driving rain tests, as well as the W1 and W2 tests that convert it. If that fails, it goes into a W3. So we'll look at all the various tests that are occurring. I have a video of a smoke test with a driving rain test, with a breathability test that you can look at, and then some other slides that we can look at in terms of what happens when it's looked at W1 and W2. So we'll eventually go through and look at all the various ISO and BS standards that a membrane has to adhere to, because it is not just about being A2. After obviously Grenfell, the big drive was about the cladding and ensuring that is A2, but a facade system is actually expected to be an A2 requirement. So effectively, given that there is now Class A2 membranes available, the approval document B Part 4 states that membranes are exempt from being part of the A2 system. You can fit a Class B S3 membrane. And the reason for that is because at that time when the documents were completed, there wasn't an A2 membrane available. Most manufacturers now will produce an A2S1DO. So I'm trying to work hard at trying to get people like DLAC, Dame Judy Hackett and the others to actually think about changing what is required in a facade system. As I said, not every facade system wants a membrane. But if you do require it, then you should now consider the A2 membrane as being a requirement with W1 waterproofness. Now, what we're saying is effectively that smoke can lead to hospitalisation. So over 50% of hospitalisation generally comes from smoke. And a lot of people don't actually know you can only use 3 breaths of toxic smoke to render a person unconscious. That's all it needs, toxic smoke of that amount. So anything we can do to reduce the amount of fire and smoke and hot droplets from a building has got to be of benefit. Because we know we're talking about here, we're talking about the outer facade system. Now, membrane is a generic term, and people have said to me, oh, well, what about it? Can I use it as a damp course membrane? Can I use it as a roof membrane? What we are looking here is at the vertical wall membrane, because the manufacturing process for the roof membrane damp course is entirely different, and it's a different application that we're getting. So what we're trying to do is get a product that effectively will give better visibility, because if there is a fire on the outside of the building, we don't want any smoke to be pulled through any of the windows, the ventilation systems into the building. So anything we can do to reduce the amount of fire and smoke has got to be a benefit. The other thing to remember, in England, we consider A1 as being a non-combustible product. We consider A2 to be limited combustible. So a lot of people are now turning around saying, actually, we ought to be turned around saying our product is class A2 S1DO. Because effectively, if you go to Scotland and the rest of Europe, they actually think A1 and A2 are non-combustible. But in England, we consider A2 as being of limited combustibility. Now, what I'm showing here, this slide effectively shows what can happen to the insulation when no breathability or no W1 membrane was fitted. Now, the cladding was fitted over W2 membranes, and because of the high humidity, the actual thermal blocks could not dry out. So what ended up happening, when they actually took away the cladding and identified underneath the membrane that was there, that actually water had penetrated through with moisture, and then mould started building up. So eventually they had to take the whole thing down. Now, this not happens on all buildings, but it just shows you what can occur if you don't get the correct membrane that you're looking for, the application, the location, etc. it goes through. So that just to show you what can happen if you haven't got the wrong. If you have a class W3 or a W2, potentially I always recommend try and go for a W1 waterproof membrane. Now, a breather membrane effectively is there to assist in avoiding condensation and removing any moisture that could have been left in the building. Because when you're fitting up the thermal block and you might have the membrane on top, it could be exposed for up to 6 months. We was talking this morning and saying there's a project and it was 2 years. So what you're trying to do is ensure that you don't get any sort of water penetrating, but you can draw moisture out. Now, when they talk about the moisture and avoiding condensation, it's similar, a membrane that says it's breathable, to the human skin. Because you can get driving rain on your skin, but it doesn't penetrate through. But you get hot, you sweat the moisture out. So it's the same sort of principle where you're not letting water in, but you actually want to let any sort of residue moisture that's in the building to let it out. Now, effectively, if it's an open facade system, you could actually want the membrane to have at least 5,000 hours of protection, of UV protection, because you don't want the sunlight to start breaking down the membrane before it's been carried out. If it's a closed membrane, it could be 336 hours. So it's all about what the architect is designing and what he wants to do with the actual building and what he wants to get from his membrane. Now, another aspect that you should be thinking about, because we talk about, as I said, the actual fire protection of an A2 S1DO, but there are other aspects, like I mentioned, the W1 waterproofness, the breathability that can be coming out. And effectively, what we should say, we actually don't want any fire shrinkage. Because again, one of the companies has said to me, well, what about fire shrinkage? If there is a fire, is it going to pull away from the actual building and therefore lose its fire protection? So you should be asking the question, have you done any sort of fire test to ensure there's no fire and no shrinkage that come through? So there's a lot of scenarios that eventually you can look for from a membrane. You want it to be fireproof as much as possible, limited smoke, no hot droplets. You want it to have UV, high UV protection. You want it to be breathable. And there's other issues as well that fold becomes an issue, because when it's on site with a site engineer, when he's bending it, he ends up being in a situation he doesn't want to actually have all these issues as an installer. So we're just going to do a quick review, new now, hopefully, on the fire and smoke test that is carried out. And if this works, we'll see it now. And this was for a fire test comparing Class E and Class B membranes and Class A2 for a fire test in the amount of smoke, followed by, which we'll be looking at, a water test, a driving rain test, then a breathability test. And it's really to give you an understanding of the sort of tests that are carried out. Now I'm going to move the video on actually because of time limitations that I've been told about. So we'll move on to the next scenario that occurs in terms of the water test and the breathability, but we can come back to that, and a copy of this video is available on the Stamisol stand if you want to have a look at it in detail. Now the thing is, we've got to remember effectively that all manufacturers are required to perform age testing with 336 hours of UV exposure before they move into a water test when they're looking at W1 to W2 membranes. So an age test should carry on, because you think about it, what you want is if it's up there before you fit the cladding behind it, you could have the sun on it and a breakdown on the UV rays. So a manufacturer will be effectively looking to say, right, I'll do a UV test, then I'll actually end up doing a water test. Now, a water test that you're looking for W1 actually has a dye water passed from underneath, passes through onto a paper gauze material. And as soon as it goes through after that, this was done on why I mentioned about A1 not having the waterproofness like an A2. But as it passed through, you can already see that the actual membrane is starting to take dyed water come through on product Y and then into product X as it comes through. Now, effectively, what you've ended up seeing there is that after the 1 hour test, it was actually only the Stamisol Safe 1A2, W1, that passed the water test for an A1 process. So what you've ended up happening effectively is that it was the 2 other units that were the A1 failed the water test for A1. But what that means is it can then process on to a W2 test. So you've got the A1 test that moves in to a W2 test as well. So a W2 test, what you're doing is pouring water upon the membrane itself, and then what you're considering there is to see the amount of water that can penetrate through the membrane to the bottom tray. There's a glass filter underneath that you'll be able to see how much water comes through. So after 3 hours, effectively, what's ended up happening, you can actually see the water penetrating one of the products with only a little bit of drip coming through on the other product, which was the A1. So what you'll end up happening, because of that scenario, you're now in a position that both the A2 passed, one of the W1 passed the W2 test, but one failed. Now, a product that fails the W2 test will automatically be given a W3 status. Okay? So it fails a 1, fails a 2, it will automatically get a W3 water status that comes through. Now, we've talked about the tests for W1 and W2, and the other tests that have been asked for is things like fold tests. Now, here is a fold test. Now, it's had 120 passes passed over with a heavy-duty roller to see how much creasing, or if there was a fraying of the membrane, which will affect what's going on by the installer on site. Here we can see a pull test, and what's happening there, pressure is applied and pulled up on the membrane to see how much pressure can be applied to it before it pulls apart and fray, because they are important factors in terms of what goes on site. Now, I'm going to rush through these now because of the time constraints, but there are a number of EN and ISO standards that are membrane. There's a copy of this again on the Stamisol if you want to see all the various standards that come through. So you've got all those standards about flame retardancy. You've got all these coming through when it comes through for tensile strength to EN standards. And you've got all these standards when it comes to UV, etc. As I said, there's a copy of this available on site. Now, I'll leave now on terms of this message from Dame Judith Hackett. Dame Judith Hackett, she was at the Construction Leaders Summit in October. And the key points is up there what she's taken away from that. The new Safety Act, the new Health and Safety Act, which comes into effect in April 24. There will be changes, she said, to approval document to improve and continue. Competence, compliance with independent testing is going to be the driving force that comes through. So they're going to be paramount to what's going to be coming through in the future. So that's it. Thank you. I believe I weren't too far over time, and I won't get too much of a rest of it.
Good afternoon. We're here to talk about, is unitised curtain walling dead for new build high-rise residential? Which is an interesting question. And we're going to discuss this in the context of a new high-rise residential project, plot 103 at Greenwich Peninsula. With me to discuss how the facade selection, why we've gone for the system we have. I'd like to introduce my guests. I've got Tom Calloway, Head of Construction from Night Dragon, which is the developer behind the Greenwich Peninsula project, which I understand is Europe's largest development project. I've got Richie Biniage. Yeah, right. Okay, good. Who's Associate Director, and Mace signed a framework agreement with Night Dragon to deliver the whole project. I've got Chris Wilkinson, Managing Director of Joe Cowan Architects, who is the delivery architect for plots 1 and 2. I've got Richard Till, Chief Commercial Officer of KGC, a Lithuanian facade company, who I believe you're currently doing a project in Liverpool.
We're testing the Liverpool system next week, and we're on site with a project in Hammersmith at the moment.
Okay.
Accommodation.
Okay, and last but not least, my colleague Manuel Dos Anjos, Senior Facade Engineer at FMDC. So what we're going to be talking about is how, what facade system we've come up with, what were the main drivers, and the particular design criteria which has driven this is a very, very low U value. So I'd like to ask Tom to give some words about the Greenwich Peninsula development and what are kind of the drivers for the project, maybe what's built and what's coming up.
Yeah, no, absolutely. Greenwich Peninsula is a large master plan all around the O2 arena. So it has a lot of both conditions in the ground, you know, with the Jubilee line and the Blackwall Tunnel. You've got the O2 with the noise breakout from there. And then also it's quite a windy place, the peninsula, so it has to respond to all these environmental factors. In terms of the master plan, it's a 17,000 home master plan, so predominantly residential. However, there is some culture and some commercial workspace there. To date, about 2,500 homes have been delivered, so there's a significant journey to go on the 17,000 total. Plot 103 that we're discussing today is a plot that looks over the Canary Wharf Way, very high-rise building. And I think the panel is going to talk about it, but really for Night Dragon, it had to be a very high-quality architecture, but given the cost of living and inflation and construction, the budget was extremely tight, combined with the challenges we just spoke about of the O2 noise in the tunnel. And it was how we could overcome all of these factors and avoid, you know, active cooling to still have an affordable product that was really important to Night Dragon.
Okay. I'd like to ask Richie about, we were talking about a 30-storey tower. We know that plot 1 is 20 stories, which is being delivered in brick-face precast concrete with punch windows. And I'd like to ask Richie just to describe Mace's view about what's suitable facade systems for 30-storey towers and what you see as your drivers.
Is that better? Yeah. For us, there's a few factors we need to consider, and it's the optimum factor. So we look at carbon, we look at quality, and we look at logistics.
Yeah.
For precast to go up 30 stories, it's not heard of, but there is an optimum, I think, where we can go to height of precast. We also need to look at logistics of precast, and it's very hook dependent. We're in quite a windy area there on Greenwich Peninsula. And the logistics of getting 12-ton panels and actually installing them, the optimum solution for us is usually unitised, because we can there's less deliveries coming to sites. We don't need external access, and if we're using a built-up wall, we tend to have much more deliveries to site. So again, the carbon content of that goes up, and it's the workmanship piece. So we know at Mace that off-site prefabricated solutions reduce our defects by about 30%. They also reduce the carbon by about 20%. And in terms of safety, what we don't want to be doing is building very, very tall scaffold and built up walls off site. In terms of program, if we're putting mast climbers up, there's big leave-out zones for the ties. So for us, Unitised is normally the preferred optimal way to go.
Yeah. Manuel, maybe you could describe, we now know that Unitised curtain wall was kind of the way that the team wanted to go, and we know that we had a very low U value. Could you probably describe what we looked at and how we developed our design?
Yeah. I'm going to sound like a broken record, but the most important thing is start from the architects and big picture thinking with them. Fortunately, we started working at stage 2, and we managed to sort of highlighted the key items to put us in the right path to meet the low U values. So one of the first things that we talk about is minimizing framing, right? So rather than having a glass panel in the middle of the panel, right? You just put it to the side and you eliminate one intermediate frame. So it's that, it's that type of thinking. Then we also looked at glazing ratios. So I don't think nowadays we can have resi buildings with glazing ratio upwards 50%. So that was a very important discussion and crucial at the time. Then we also had to think about panelizations, right? Because we want panels as wide as possible to have a bigger area to sort of spread out the thermal bridges. But there are hoist constraints. We don't want to use tower cranes to install the panels. So that's one crucial thing to look at.
And what panel sizes did we investigate?
So ideally, typical Unitised is what, 1.5, right? Yeah. Ideally, you want to double that to 3. Yeah. But of course, that doesn't fit in the hoist. Yeah. So we ended up with something about 2.1. Yeah. Which, given the external features that we have, well, you cannot see it here, sort of you could easily fit it in. So that's the place, the good compromise that we get to. And then lastly, the location of the vent. So that's a very important one if you want to meet low U-value targets, because usually architects want the vent in the opaque area, and that's your best performing area. So you rather take the hit on the glass area, which is the lowest area of your panel. So once you set all those 4 parameters in the beginning, right, and of course I said in the beginning because all of those things that I talked about has an impact on the architecture, not only externally but also internally in terms of layouts, then you can then start thinking about more detailed kind of nitty-gritty details of the facade. But like big picture thinking, high level, that has to be set out from the beginning.
And what U value did we achieve in our calculations and design?
So we managed to get it to 0.65 after a couple of iterations, different architecture, panelization. So we managed to get to 0.65. Okay. That was at the end of stage 2.
Okay. Richard, maybe you can say about how KGC became involved in the project.
Yeah, hi. So we were asked by Mace to have a look at the scheme. Thankfully, many of you probably know, I have a very long-term colleague, Allan Anthony. Unfortunately, he's not here today, but he's testing in IFT, but we've worked together. Next year will be 30 years. So he is really the core of the knowledge, and his team in Basel, the core of the knowledge, and we joined KGC 2.5 years ago. But what that team really brings is what I've seen in the market is that if you went back a few years ago, U values were relatively easy to achieve, and architects could design whatever they want. Our system designers could design whatever they want, and the engineers basically made the thermal performance, which was the key driver, made that work. Now, with the latest iterations and the latest changes, we are quite clearly entering a new era in our industry. I think the headroom, if I call it like that, on U-value compliance is going away. We have to have highly engineered systems to get. So here, for example, we have a Unitised curtain wall which has balcony penetrations, MVHR connections, opening vents, sliding doors, all the things which leak watts. and which make U-value compliance very difficult. We are optimizing that system by using a bespoke system, so we can move thermal breaks backwards and forwards, in and out. We can fully optimize that system and each detail that we're using to get those U-values down to get a compliant system. Now, what we're doing in doing that is we have our building physicists and our system designers are working literally, whereas before it was probably the system designer went off and drew, and then the building physics guys said, we're okay. Whereas now, the engineers now, this is where I think it's the new era, the engineers, specifically building physics people, are now leading the design, and they're telling the designers, yeah, you need to change this. You have to change the size of that vision glass. It's real fine-tuning, which is taking us from the old U values we were looking at in residential of 0.7, 0.75, down to 0.6, 0.65. And here, I think we've got one building down to 0.6, including all the balcony penetrations and everything else, and the other one's at the moment 0.63, but we're fine-tuning the last bit. So you can see where the industry's going, and I think now that new era is not just going to be about U values, it's going to be about embodied carbon, and we now need to start not just doing value engineering on a money basis, we're doing on a cost basis, we're doing effectively the equivalent of value engineering on a thermal basis, and we're going to start doing it on an embodied carbon basis. So whereas before you just had one list with costs and the client went, I'll take that, I'll take that, I'll take that. Now we're going to have this debate of, well, if I take that, the embodied carbon's this, the U value is this, and that will generate a whole new sort of process in what we're doing, and that will come earlier in the process, maybe into late stage 2, early stage 3, whereas before, we were getting the knock on the door at stage 3, stage 4. So I think that's what's fundamentally changing, and I think that doesn't just change for us doing what we do, it will change for architects and yourselves and the M&E consultants at your level as well.
Yeah, I'd like to bring Chris into the discussion and ask about your approach to deliver the performance. I mean, I think it's fair to say that that Joe Cowan didn't do the planning design, but you've taken it over. And I understand the building was approved by a committee yesterday
Last
evening.
night, yeah, which is always a relief. So we're working with Pilbrow and Partners, who are the concept architects for this, and we stepped in at the later stages at point of working with the delivery teams, and with that comes a lot of pressure because you have to uphold the design and the intent of another designer first and foremost, which always means that you have to hold that very preciously. You don't feel the same liberty to modify in the same way as if one were the original curator of that. I think one of the key challenges really on a scheme like this and on any residential unitised scheme is understanding the pace at which you can design it. They're highly complex buildings, they're fraught with challenges, and obviously we have clients who have very strict criteria for mix, and the brief that comes with that can often lead to decisions that ultimately filter through to the facade systems, and that'll be through placement and positioning of windows, as Manuel mentioned, about vents, etc., and really about trying to look how you can optimize the quality and the performance of it whilst upholding a design standard that's been set, is a key challenge there. And I think that one of the primary aspects we looked at was how to reduce the quantum of framing across the scheme, and that comes very carefully in consideration with how your apartments are working. Another key challenge as well that was touched upon is positioning of balconies as well. You have much more freedom and flexibility as an architect if you have a slab penetration balcony connection. It gives you that ability to fine-tune the positioning of it. You don't have to co-align it with mullions, and you can set them as you wish depending on the door opening and relative to Part M conditions with nib edges against the doors, etc., etc. So there's a lot of fine-tuning that comes with it that have quite fundamental impacts on the performance and the value of the U-value performance ultimately of the building. And so I think that was the absolute key criteria for a lot of this, was about ensuring the performance whilst upholding the design. So the two in hand came together.
Okay. I'd like to kind of drill down into the detail. How are we actually delivering 0.6 U value? Is it the curtain wall alone? Is there an internal wall? Where is the vapor control line? All the usual dew point issues. I mean, that's open. Who wants to answer that one?
Can I go, Richard?
No,
you can start.
Okay. I mean, look, you have to take advantage of everything you have in the system. So if there is dry lining, put some insulation in there, as long as you do the dew point issues and check all of that to make sure you're not creating a long-term problem, very similar as we saw about membranes and things like that. So we do all of those checks. That's important, I think, but the reality is how to get to where we get to now is really, we are looking at new products. So I don't really want to go into it in this environment because it's, that technical advantage at the moment. It won't last forever, but we're looking at new products. We are playing with the system literally to the tune of millimeters to optimize each detail, to get those thermal contours running through very smoothly, coming from opening vents, through mullions, through element joints, into insulated panels, around brackets. We even engaged in this process with the balcony suppliers, thanks to Mace. They helped us, and we had meetings with them, so we got their details and we coordinated their details to put those into our thermal models, so we know exactly, we're not guessing a value and saying there's an arbitrary value for a bracket. We've modeled the bracket and we know the heat loss through that bracket. We've done that for every detail, so we end up with a thermal report on this job, probably more than 100 pages, I guess, isn't it? Yep. Good reading if you like it, yeah. But it shows the level we're going to as a business now and as an industry.
And who are you providing the drywall behind your curtain wall?
No. What we're doing is in our report, we state the performance, the insulation depth, the lambda value of the insulation, and we also give other factors. We're not putting foil-faced insulation in. Foil-faced plasterboard in, so we're not trying to put vapor barriers to the inside specifically, but we do give performance requirements for that in order to balance the system, to make it work, to make sure we don't have condensation issues.
Okay.
Can I add something?
Yeah, of course, carry on. Yeah.
So, apart from everything Richard just said, we also looked at chamfering, framings, integrating the profile of the sliding door to the transom stack joint. So we looked at all of these little detailed things, and this was before your involvement with stage 2. So how do we deliver low values? You need to go all the way down to the detail on stage 2, which is supposed to be a concept design.
Yeah.
So that's, and then when KGC came on board on stage 3, we then sort of had more certainty that the things that we wanted to propose and the things we wanted to do, the facade subcontractor got buy-in and can say, okay, yeah, I would like to do that. That sounds like a good idea. No, I don't want to do that. Why don't we do this? And start that type of collaboration.
Yeah, we haven't mentioned embodied carbon so far. I understand there's a target, and I believe the target was about 146 GIA, which with the form factor relates to about 292.
Yes.
I understand that we are about 302 without a safety factor, A1 to A5.
Yes.
I believe, Richard, you submitted the embodied carbon report a few weeks ago.
Did I?
Yeah, you did.
Yeah, thank you.
I think we've returned its status C. B.
B with comments, please.
Yeah.
Showing you true colours there, Simon.
Yeah. I mean, do we see some progress in that? I mean, a lot of the figures are based on the CWCT kind of guideline figures. Where do we think we're heading?
I mean, obviously, we've prepared and we've coordinated a whole embodied carbon calculation system with it, and we've synchronized, for a nice way of putting it, maybe that with yourselves.
Yeah.
You helped us a lot in the early days of formulating that. So, but what we're ending up in a situation is where we are reacting to the architecture. If there's a mullion there, we can't make that mullion disappear. If there's a metal panel with a shape on it, we can't make that panel disappear. So I think at the moment we're in a scenario where, as I said earlier, we're probably entering into a new era where embodied carbon is going to start informing the design as to what we do. And that will get really interesting because if I look at some of the other projects we've looked at, no disrespect, gents, but we looked at a project in Manchester and we did quite a bit of work on it. And we started with an embodied carbon. We had 272. And we just said, okay, what can we do? We went away and we optimized all the profiles, optimized the design without changing the fenestration. We were straight away down to 234. And then we've got all these other products we can bring into play, like the Circal, and there's glass options and things like that. So I think as time goes on in this business, maybe for the next we find that this building is kind of locked in where it is at the moment for 103. But in your next buildings, I'm sure you're going to be asking us, right, do more, do more. And that's when I think we'll end up doing a lot more coordination with yourselves and the rest of the team to say, right, this is where we're going to go with the embodied carbon.
Yeah, I mean, I think we're entering a period of carbon-led design.
Yes,
and
I think so.
And what's the architecture going to be?
Yes.
And I mean, where do you see like the U values going on unitised curtain wall? How low is low?
Well, this is the question, isn't it? Ultimately, I think on unitised curtain wall, we're now. I asked Allan, Anthony, once again, I every now and then over the years, I've said, oh, you haven't been very innovative recently, come up with something new. And he gets slightly a bit annoyed with me, and then he runs away, and he does some amazing stuff, absolutely blows my mind. So I asked him, I said, look, in the years to come, what can you do? And I said, we're probably at some point in the next 2 to 5 years going to need curtain walls with 0.4. It took him 2 weeks to develop a system with triple glazing, so nothing out of the ordinary, but just fully optimized. Now, when that will inform the design, it will inform mullion centers. That had, just to be clear, that actually had 46% vision. So it wasn't as though we made a very small window and a lot of panels. We ticked a box. But it shows what we can do. It shows where we can go. And ultimately, we won't end up with 0.4 curtain wall because we're going to have balcony penetrations and VHR opening windows. But we will have to maybe look at how the amount of them we incorporate into a facade to make it work. And this is where this interaction between building physics people, embodied carbon, in our company, the same people do the embodied carbon and do all of our building physics. So that's like a one discipline working with the designers. But eventually, all of those things are going to come together, and we're going to end up with facades, I would guess, 0.45, 0.5. But I think it will also plateau because of overheating.
Yeah, exactly.
So maybe you should comment better on that if you don't mind.
Yeah, when you said about 0.4, I was like, oh, overheating, maybe.
Yeah, exactly.
Well, that ties to glazing ratios as well and all that stuff. The good thing about, all the things that I talked about previously, the principles about high-level thinking, is that it also helps for embodied carbon. So, less framing, less aluminum, lower glazing ratios, less glass. So, glass being a super high carbon-intensive material. Yeah. So, to our fortune, it sort of blends in a way those two things and helps us. But yeah.
I'm just wondering if this is going to have an effect on the procurement. I mean, Richard and I were talking before about PCSAs and possibly saying that was, probably too late. We need earlier involvement. I mean, Richard, do you want to add something like that? I mean, is a PCSA too late? I mean, do we...
I would probably suggest it is. I think the involvement at stage 2 in the collaboration and talking with the building physics people, the specialist subcontractors, the facade consultants, and the client, and actually thinking about what is it we're looking for at the end of this process. Are we looking for the most cost-effective tower building that we're building? Is it the one that we can build the quickest? Or actually, is it the lowest embodied carbon, the most cost-effective, with the best architecture that is fit for purpose? So the earlier we have those collaborative discussions, I think the better the results that we get at the end. The PCSAs, in my opinion, are probably a little bit too late. They're just optimizing what's already there without an opportunity to develop that further.
I mean, certainly we're seeing clients come to us, and sometimes before even main contractors are actively involved, they're coming to us and saying, look, I've got this scheme, and they're literally giving us their planning drawings. Yeah, this is the planning submission we've made.
Too late then. Too late.
Yeah, but they give a very early, let's rephrase that, a very early stage package, and they're saying, give us a price, a cost plan, give us a set of proposals, and we will literally do a set of system details, mostly a U-value assessment, an embodied carbon assessment, and an acoustic assessment often. And if you have those 4 key characteristics, and then a price, obviously, because that's the point they really want to know. And if we have those characteristics, and we tend to write like a small, it's not a specification, it's a technical proposals document, maybe 30 pages, which describe, with price powder coating, we've used triple glaze units with this G value. All the key parameters are in that document. And when you bring those things together, which is what we did here to yourselves, that gives them, the client team, confidence to say, this isn't just the Wild West. The facade contractor can't just run off and do whatever. They've got a set of parameters from us, and they say, yeah, that works, or sometimes come back and say, yes, but can you do this? But we very quickly reach an agreement at often a stage 2 as a route forward. And in that stage, then we're working with yourselves and saying, okay, this detail, can we do like this? Can we move that? Or can we move that balcony over, weren't we? We were playing with all of those things.
Yeah, absolutely. I think that point, just to go back one step there, that the point you're making about some of the work that you're doing to get U values down to, say, 0.4, for example, really highlights for me that issue about what stage involvement happens. And for me, the earlier the better. Now, that's sort of a bit of a double-edged sword as an architect, because you end up hamstringed by being controlled ultimately by the delivery end of it, when you still need that freedom up front to be able to design and curate things, particularly with regards to impact upon the urban realm aspects to it, neighbouring buildings, etc., etc. And you need that freedom to be able to be responsive. But I do think it's changing so much that we need to find that balance point between finding incredibly good systems that are really well controlled and using those as a design tool before you lose that opportunity. And I think particularly with the level of detail that's required of planning applications, the amount of reporting, CGIs, etc., Bay models, details, 1 to 20s, 1 to 10s sometimes, that control and fix so much of it. It's very hard to unwind some of that. So I think that early involvement is really, really critical.
Okay. We've got to wrap up now, so I'd like to ask Tom, the client, to maybe just say a few words about the process so far. Are you happy with the way it's going? Are we...
We're doing a
yes,
terrible
we're
job.
happy.
Is it going the way you want,
No, I think it's been a really good process, a very collaborative process, and I think we definitely wouldn't be where we are today. Fantastic that we got planning, but we wouldn't have had a scheme that we could submit that we knew would be buildable without this very early involvement. And I think that it's been invaluable having both the subcontractor and the main contractor sitting by us early on. I think where we need to get to is it does all still feel very bespoke. So we've kind of got, say, 6,000 more homes to build in this area. A hell of a lot of work went into getting this 900 unit scheme. But if you multiply that work by every single building left, there's a huge amount of time and money potentially. So I think that toolkit approach that Chris was referring to, and with this team, that's really where we need to get to. We can't do this level of engineering on every single one of our projects. The viability is so stretched already that I think it's been a great process, and I can't speak highly of this team, but it feels to me that the next step of this process is the standardization part, the toolkit part, the faster route to market part, and we need to know very early on, will the building need cooling, for instance? That's kind of £3 million swing. So we can't wait till that gets further down the process. So I think it's really a case of super positive, but a long way to go before we can just have some real confidence and agility in the design process at this very technical level.
I think it's also like a learning curve thing, because for us, it's probably the first time we're delivering a resi with a new Part L. And then that part of meeting the U value as well, it's a challenge. And it was a key question to figure out. I mean, once we sort of answer that, then we can then...
Okay, thank you very much.
Thanks, Tom.
I'd like to thank Tom, Chris, Richard, Richie, and Manuel. That was fantastic. Thank you.